Hi again, welcome back. This little short video is just going through one really average question based on internal resistance. Okay, so I'm just going to draw the picture. So we have one cell, two cells. Okay, attached to that, we have a resistor, and this resistor reads 1 ohm. Okay, then the circuit then goes and it says it's going to have an 8 ohm resistor over here. Okay, so that one's 8 ohms. Then it's going to have a resistor over here, and this resistor happens to be 5 ohms. And then we also have another resistor that is attached over here, which is 10 ohms. Okay, these two combine, carry on, and go up here. Then we have a dotted line around here. And as in my last video, I told you when there's a dotted line, that is representing that the battery has internal resistance. So this part over here goes together and tells us that it is the internal resistance portion. Okay? First thing we need to identify is that as we come down the circuit, when we get to this point, our pen doesn't have to split. It can go right through this resistor. So this means that this resistor is in series. Okay? We then carry on with our pen. We get to this portion and, oh no, my pen has to split into two, which means this is parallel. So R parallel 1, and this is R parallel 2. Okay? When we get back to this section, we then turn back into being series. Okay, you really need to understand the concepts that these are entailing. So you need to understand that this is a series and this is parallel. That when you are dealing with parallel circuits, you need to use the equation 1 over R parallel equals 1 over R1 plus 1 over R2, and as it goes. And when you are dealing with series circuits, you then just add them together like R1 and R2. Okay. So there's a different way of calculating them, especially when the question starts asking you for the total resistance or the effective resistance, or if they want you to find R external. R external is the R total in the whole circuit, which is your R series and your R parallel together. It is not including this 1 ohm. This 1 ohm belongs to the internal resistance of this battery. It's got nothing to do with the rest of the circuit. It's there so that the battery can do work. So it offers some resistance to the battery so that it can use energy that produces the charges to then be sent around the rest of the circuit. Okay, so question 1 is just saying calculate. So calculate the current, I remember as measured in amps, calculate the current in the 8 ohm resistor. That's what the question is asking you to find. Okay, so to calculate the current in the 8 ohm resistor. First of all, I'm going to look and I'm going to say, okay, what have they given me? So the question said that the battery has an EMF of 20 volts. So it's telling me that this whole part here, the whole of the battery is 20 volts. That's the EMF. It's not the potential difference. Okay, it's not the potential difference. It's the EMF. It has 20 volts. And the internal resistance of this resistor is 1 ohm. So that's what the question told me. This is the diagram, and now they're asking me to calculate current in the 8 ohm resistor only. Only in this 8 ohm resistor. Okay, they haven't mentioned anything about here, but we might need to use them. So we need to decipher a little bit. Okay, so I want to find the current in the 8 ohm resistor and the 8 ohm resistor in series. So I need to find I total. That's what they're asking me to find. They're not asking me to find an ammeter reading here that is in series. That's not what they're asking. Parallel. It's not what they're asking. They're asking for the current in the series portion. So it would be as if the ammeter is over here. They're asking me to find this. Okay. I don't have V total. I don't have the total external. Okay, so V external. You could also say is V total. I don't have the V total or the V external. I only have EMF. Okay, the EMF would be how much voltage this resistor is using plus the external. Okay, so remember, EMF is equal to V internal plus V external. We know this is 20, but we don't know what these two are yet. Okay, so I want to find I total, but I don't have V total. I only have EMF. Okay, so can I work out V external? Can I work this out? No, because I don't have enough information. I don't have V internal, so I can't find V external. So I can't use the equation R is equal to V over I, because yes, I can find R external because I have all three resistors amounts. So I have the ones that are in parallel and the one that is in series. I can work out what R external is, but I can't figure out what V external is so that I can figure out what I total is. Okay, I can't do that. So I'm not going to use that equation. I then must be able to use E is equal to I R plus R. Surely I must be able to use this equation then. Okay, so it's about a process of elimination. Sometimes you can't just jump into one equation. You need to see what do you have of each one and then go from there. Okay, let me just change my color a little bit so that we get a little bit. Okay, so the EMF, we already know we have 20. The question gave it to us. I know that I'm trying to find I. Capital R is the R external. I can find that. I do have that. I have 5, 10, and 8. I can work out the total effective resistance in the circuit to be able to add it to here. And I know that the internal resistance is 1 amp, because 1 ohm, because they already told me. So I need to do a little bit of extra calculation to find this R external. I'm going to do it on the side here, and then we're going to come back and we're going to add it to that. Okay, so I know that R external is going to be my R parallel and my R series. My R series is fine, it's the 8 ohm, that's okay. But I need to know what my R parallel is. And the equation for R parallel is 1 over Rp is equal to 1 over R1 plus 1 over R2. R1 they said was 5 amps and R2 they said was 10 amps. Okay, so it's 1 over 5 and 1 over 10. We need to find the common denominator between 5s and 10s. Obviously, it's a 10. Okay, 5 goes into 10 twice, 10 goes into 10 once. So it is actually 3 over 10. But what we need to remember is that it's 1 over R parallel. I don't want 1 over R parallel. I want R parallel by itself. So what you do to the one side, when you flip this around, you need to come and flip this around, which gives 10 over 3. And 10 over 3 is 3,33, okay, which is equal to 3,33. We add that 3,33 to the 8, and we get an R parallel and series together to be your 11,33 ohms. We then take that, just change the color so that's a little bit different. We then take this 11.33 and we can then sub it into here. Okay, so this was 20. I is what I'm looking for. R external is that 11,33. The internal resistance is 1. When you put it all in your calculator, your I is going to equal 1,62 amps. And that's your final answer. This would be about 5 marks. Okay, obviously it's equation, substitution, answer, and then 2 marks for whatever the government decides where the mark allocation goes from. Sometimes it's adding the 8, sometimes it's knowing what the denominator is. It just depends on where they say that the mark should go. Okay, then I want a new page. Then question 2 then goes and says both resistors have the same voltage. Okay, so the question asks to calculate the potential difference across the 5 ohm resistor. Okay, so calculate the potential difference across the 5 ohm resistor. The 5 and the 10 ohm resistor are in parallel. Okay, they're both in parallel. So that means they both have the same potential difference. Because remember, the rule for voltage in parallel is that they equal each other. The voltage does not change because the voltage is even. Okay, so we know that both resistors have the same voltage. So we can say the voltage in the parallel system is 5 and 10 together. Okay, so now we're not going to use the the EMF is equal to IR plus R. We're not going to use this equation because we know we're not dealing with anything. The only other equation we have is R is equal to V over I. So let's think about it. Do I have the total R parallel? Yes, I do. I worked it out in the previous one to be 3,33. This is just the parallel section, okay? So I have R parallel. I worked it out. I'm trying to find the potential difference, the voltage in the 5 ohm resistor, okay? And what did we just work out that the current was in the whole circuit? It was that 1,62. So it makes it really easy so that V is equal to 5,405, which we can then change to 5,41 volts. And that is my answer. Equation, substitution, answer. Okay, so in retrospect, you had to understand that the 5 ohm and the 10 ohm equal each other in voltage. We already have the parallel. We already have the voltage in parallel. I mean, not voltage in parallel, the total current in the whole circuit, so we can work out the V parallel section. Okay, so the question is quite nice. It's a nice, simple, it's a normal question that they will ask in grade 11 and maybe even in grade 12. They are really not as difficult as you think that they're going to be. You just need to slow down. You need to identify, is it V external? Is it V internal? Is it EMF? Is it potential difference? Is it R external? Is it R internal? What are we dealing with? Are we dealing with the epsilon equals IR plus R, or are we dealing with the R equals V over I calculation? So please don't overcomplicate it. Take it slowly and actually know what has been given so that you can actually answer the question properly. Okay, thank you. Bye. Bye.